Alrighty, good people. We are talking about determinants and inverses of matrices here. So titling your notes, putting the date down. You don't necessarily need to write this into your notes, but just a few things to kick it off here. So only square matrices have determinants. Okay, so it's like a 2 by 2, 3 by 3, 4 by 4. Remember our rows and our columns. The determinant of a matrix could be notated as any of these three things right here. Sometimes math symbols need to perform double duty here, so that doesn't mean absolute value if we're talking about matrices. That means the determinant there. And what is it? The most basic way to talk about it is it's a scalar value of a square matrix that is very useful in linear algebra. So we don't get to go super far into the applications here at this level, but we want to make sure you know how to find it so when it comes time to using it, you're ready to go. Okay, so the determinant here, if I have a 2 by 2 matrix, notice here we multiply across this diagonal, and we subtract what we get when we multiply across this diagonal. That gives us the determinant of a 2 by 2. We'll talk about a 3 by 3 here shortly. Okay, so we want to find the determinant here. Just a couple of examples. We've got a 2 by 2 matrix. We're going to multiply across this diagonal. Okay, I would, in my notes if I were you for this very first one at least, write down each of those numbers. Okay, if you start to feel super confident with this stuff, maybe you don't feel like you need to do that in the future, then we're always subtracting what we get when we multiply across this diagonal. Watch your signs here. Okay, I go to clean this up. We're looking at 2 plus 10. We end up at 12. Okay, let's look at this one. Multiply across the diagonal. 6 times 5 would give us 30. Subtract what we get when we multiply across this diagonal. 18. Now that's just a coincidence that both of those, the determinant was 12. It's not always going to be 12, just a coincidence on those examples that's how it shook out. Okay, let's talk about a 3 by 3 here. Now there are some different ways of doing this. If you look at Delta Math, they go through a different way. If you look on YouTube for other ways to find the determinant of a 3 by 3, if you prefer one of those methods, that is totally fine with me. In my experience, this is just my personal favorite. Okay, so we're looking at this. We are going to add 2 columns, okay, because we're still going to have that diagonal work. So what I'm going to do is take those first 2 columns and just repeat them right here. Okay, then we're going to do some diagonal work here. So I'm going to multiply this diagonal, add it to this diagonal, and add it to this diagonal. Okay, so we want to be really careful with our work here. Work on keeping things organized. Okay, I'm going to use some brackets to group here. Okay, multiply across that first diagonal. Again, in this first one, I would write each and every step. Okay, that way you can look back at your notes and say, oh yeah, that's what I was multiplying here. Okay, then we're going to subtract what we get when we multiply across the other diagonals. So let's grab another highlighter color here. So by that I mean this diagonal, and this diagonal. Okay. All right, there are so many spots we could make a silly mistake, so I really encourage you stop right here, double check things, make sure your signs went the way you want them to go. That's the nice thing about showing each step here too, is it helps you see what you were putting in each piece. Okay, so right here, if I multiply those together, I believe I get 70. plus 300 plus 60. From that, I'm going to subtract over here 60 plus 75 plus 280 already. We keep on cleaning up here. To end up at our determinant of 15. Alrighty, now we can calculate the inverse. We've talked about inverse a lot in math. Inverse undoes something. This is going to be super useful when we go to use this to solve equations. Is our most useful application of this at this point in your math career, but the inverse of a matrix has all sorts of really valuable applications. We stop at finding the inverse of a 2 by 2. It is possible to find the inverse of any square matrix. 2 by 2 is what we worry about here. Okay, so to find the inverse, we need to find the determinant. Okay, then we take 1 over that determinant. Then notice what happened here in this matrix. Okay, we flip-flopped A and D from the original, and we change the sign on the B and C elements. Okay, so we flip-flop across one diagonal, we change the signs on the other, and that allows us to find the inverse. Okay, so let's utilize that. First thing we need to do is find the determinant. Let's see here. Remember, there's a few different ways we can notate it. I'm going to choose to notate it this way here. We multiply across a diagonal, okay? 10 times 1 gives us that 10. Then we're going to subtract what we get when we multiply across our other diagonal. Negative 10 times negative 2 will give me negative 20. Clean that up. Our determinant then is negative 10. That's not our answer, but it's going to help us find the inverse. We need that value to find the inverse. Okay, now we use that as the denominator of our scalar out front. Okay, 1 over negative 10 here. Now don't forget, we flip-flop across the diagonal. We change the signs across the other diagonal. Since they were both negative, they now become positive here. Okay, depending on what you're doing with this, sometimes it's useful to leave that scalar out front. Sometimes it's more useful to go ahead and multiply it in. I'm going to go ahead and multiply it in. We'll talk about when I would do what tomorrow when we talk about systems. Okay, multiplying each and every element by negative 1/10. You can clean up at the same time, or take another step and clean it up. Let's see, doesn't reduce there. 2 over, I was trying to reduce, that should be a 10, I apologize. Negative 1/5 then, that reduces down to negative 1, negative 1. Okay, now because that undoes the original, if you ever want to double check your work, if you put the inverse out in front of matrix A here and you multiply them, you should clean up to the identity matrix. Which is 1, 0, 0, 1. We'll talk about that more when we talk about systems. Okay, directions say find the inverse or state that there is no inverse. So let's actually see what happens here if there is no inverse. Okay, we need to start by finding the determinant. Okay, so multiply across the diagonal. Minus what I get when I multiply across the other diagonal. I get 0. Now that might be enough to you right there to say, oh, there is no inverse. If you're like, I don't know why you're saying that, Ms. Grimes, that's okay. Let's see what happens. Now to find the inverse, we know we take 1 over the determinant. That's where things get cringy. We know we can't have a 0 in the denominator, so even if I flip-flop across this diagonal, one more place to practice here, and change the signs across this diagonal, I've got something that when I go to distribute that in, that scalar multiplication right there, not quite distribution, but it feels like it, we are dividing by 0. That's no good. This is not okay. So what that indicates to me in this one, there is no inverse. Alrighty, make sure you've got some good notes on that. If you have any questions, make sure you contact your teacher to get some extra assistance, and I will catch you in the next video.